Okay, what did we have seen in the earlier classes? We have seen about ideal and practical voltage and current sources. Okay, you know what is the ideal voltage and current source. Now you know what is the practical voltage and current source. Okay, the next we are going to study about conversion of sources. Why we need to convert the sources? It's a different topic, but the in practical scenario we will be having a voltage source, example battery, but the battery source, that is the voltage source, will be delivering current out from the battery. Okay, so for modeling purposes, we need to convert the voltage source into a current source and a current source into a voltage source in some circuits to find the exact derivation or equation or a complex formula for a representation of a circuit. For doing so, we need to convert the current source and voltage source. Today, we will be seeing about conversion of current source to voltage source and voltage source to current source, and a very simple problem using current divider rule. Okay, these are the three topics we are going to see today. Okay, first we move into this topic. The first one is current source to voltage source conversion. Here, replace the practical current source into voltage source and check whether you get the same load current IL and the load voltage VL. Okay, this is the question and this is the circuit given in the question. Okay, the white one is the question and the white circuit and the given data are given over here and represented in white color. Okay, you can see the circuit, and this circuit has a current source of 3 amperes and a source resistance Rs of 2 ohms, and the circuit is closed using a load resistance RL of resistance value 4 ohm. Okay, this is a very simple circuit, and this circuit has a current source and a source resistance and a load resistance. Now we are going to convert this current source, which is in a dashed representation. We are going to convert this current source into a voltage source. So to do this, we know that the source resistance is 2 ohms. You can see it is given in the circuit itself. Rs is 2 ohms and the source current Is is equal to 3 amperes. You can see the source current is represented and it is represented as 3 amperes. And then the load resistance RL, which is 4 ohm. See, it is represented here, and the load current is represented as IL, which is here, and the load voltage is represented as VL. Voltage is measured across the load resistance. Okay, it should be measured end to end, whereas the load current, which will flow through the resistance, and it is measured via the resistance, how much current is flowing through the resistance, whereas the load voltage VL should be measured in between the resistances. Okay, load resistance. First, we need to convert the parallel resistance into series. You all know this is the parallel resistance which is connected across the current source. This is the current source and this is the source resistance, and you can see the current source and the source resistance are connected parallel. Okay, now we need to convert this parallel combination of source resistance into series combination. For that, we are going to redraw the circuit. You see, we are going to convert this current source into a voltage source. Okay, first we need to convert, draw this thing. Okay, here it will be plus and another one is minus. Okay, next what we need to do is we need to find the voltage across the source. Here in the current source it is given as 3 amperes. We have converted this current source into a voltage source. So in this voltage source we need to find the voltage across this source. To do so we can directly use Ohm's law. We know Ohm's law, V is equal to IR. V is equal to I into R. Okay, that is Rs into Is. Here, Vs represents voltage across the source which is to be found, and Rs represents the source resistance, and Is represents the source current. We know Rs equal to 2 ohm and Is equal to 3 ampere. So on multiplying this, we will be getting 6 volt. Okay, so we can directly write voltage across the source, that is Vs, that is the voltage source value, will be equal to 6 volt. Then we need to take this series current source. So we are going to convert this current source into voltage source. So you see, this is the resistance which is connected parallel across the current source. So this resistance is disconnected and then connected in series. Okay, can you understand? This voltage source is 6 volt. We have found it through the Ohm's law. After that, we are going to disconnect this parallel resistance and connecting it in series across the voltage source, and then the source resistance is 2 ohm. It is not changed. See, the Rs is equal to 2 ohm. Here also Rs is equal to 2 ohm, and then the other circuits follows as it is. See, after this 2 point, the load voltage VL is represented as it is, then the load current IL is represented as it is, and the load resistance RL is 4 ohm and it is represented as it is. So by converting only the voltage source, we have attained this circuit. So the only difference between the current source circuit and the voltage source circuit is we have converted two things. One, we have converted the current source, which is 3 amperes, into voltage source of 6 volt by using the Ohm's law. V is equal to IR equal to 6 volt. Okay, this is one thing. Second is we have converted the parallel combination of this resistance, 2 ohm resistance, into series combination of resistance added along with the source voltage Vs, and then other things remains the same. So this is a very easy conversion of current source into a voltage source. Next, we are going to verify the current source. So we know that these are the formulas. You can directly get a remember of this formulas, or you can make this formulas in your mind. Okay, the current which is flowing through the resistance, that is the IL. We are going to find the load current IL, which is represented here as well as here. So the load current IL will be equal to the current flowing from the source, that is the IS, into Rs divided by Rs plus RL. That is, the load current will be equal to source resistance into source resistance divided by source resistance plus load resistance. Okay, this is the formula to find the current across the load or current which is flowing through the load. So we know the values. Source current is 3 amperes, source resistance is 2 ohm, and similarly load resistance is 4 ohms. So we can directly substitute all the values and we can find the load current is 1 ampere. Next, we need to find the load voltage VL. We know load voltage V is equal to I into R. Okay, here we have already find the load current IL, which is 1 ampere. So I is 1 ampere and the resistance V is equal to I into R. I is 1 ampere and R is nothing but the the load resistance, which is 4 ohms. So 1 into 4 will be equal to 4 volt. Very easy. Next one is we are going to find the power across the source resistance, whereas power is equal to PS. PS is equal to I square into R. Here the I represents the source current, that is 3 amperes. So 3 square into R. Here the R represents the effective resistance across these things. So the complete resistance, that is the source resistance and the load resistance. To find the equivalent resistance which are connected in parallel, we need to use 2 into 4 divided by 2 plus 4. Don't worry how this thing came here. In the next few classes, we will be seeing about series resistance and parallel resistance, where you will be get familiar of these things. Okay, so now you know IS is the source current, that is 3 amperes, whereas the effective resistance, that is the equivalent resistance, which is this 2 ohm and this 4 ohm. To find the total resistance present in this circuit, we need to use the formula 2 into 4 divided by 2 plus 4. So we will be having the power rating of 12 watts. So these are the values which we get from this circuit, which is given in the question. So this is the verification of current source. For this circuit, we have verified the values of load current, voltage and the power across the load in the current source circuit. Next, we are going to verify what are all the values present across the voltage source which we have converted the circuit. Okay, we have this circuit is given in the question and we have verified all the values. Next, we are converted the current source into voltage source in this diagram. Next, we are going to find all the same values IL, VL and power from this voltage converted circuit. Okay, next we need to find the load current IL, which will be equal to the source voltage divided by resistance across the source and the load resistance RL. So here the source voltage Vs, which is this one, 6 volt. So we can directly put 6 over here. Next, here you can see the source resistance and the load resistance is 2 ohms and 4 ohms. Why we need to add these two things? We know Ohm's law, V is equal to IR. Okay, we know V is equal to I into R. Okay, then I is equal to V divided by R. Okay, here the V is nothing but 6 volt. There is no problem. V is directly given as 6 volt. Next, we need to know the resistance R. So here the effective resistance is 2 ohm plus 4 ohm. Okay, so we need to add these two values of resistance which are in series. So if the two resistors are connected in series, then we need to add the two values. Whereas in this circuit, what we have done is inversely taken the values. Okay, we will see these details in the next classes. Okay, for series effective resistance, we're going to add these two resistance, which is nothing but 4 ohm plus 2 ohm, which is nothing but 6 ohm, and the load current IL will come across 1 ampere. So now you can see the verification of voltage source, that is load current IL is 1 ampere, whereas here in the current source, the load current is also 1 ampere. But we have converted the current source into voltage source, but the parameters, the load current parameter did not change. Here also 1 amps, and but the current source is also 1 amps, voltage source is also 1 amps. Next, we are going to find the load voltage, which is VL is equal to Vs into RL divided by Rs plus RL. So we have all the values. Vs is equal to 6 volt and the load resistance is 4 ohm. Rs plus RL, that is equal to 2 plus 4, which is 6. Then substituting all the values, we will get VL is equal to 4 volt. So now the load voltage is 4 volt. You can see the current source, the load voltage is 4 volt. In the voltage source, the load voltage is also 4 volt. There is no changes. Okay. Then we can say both the circuits are same. Yes, both the circuits are same. It is a current source circuit where this one is a voltage source circuit, but both the circuits are same and identical. Next, we are going to find the power across the load resistance, whereas PS is the source resistance power. Sorry, the source power. PS represents this. Okay, S represents source. So the source power PS will be equal to V square divided by R. We know V represents the source voltage Vs. V square is 6 into 6 divided by R. We know R represents the total effective resistance present in the circuit, which is nothing but in a series circuit we need to add 2 plus 4. So we have given 2 plus 4 and we are having 12 watts. Okay, V is 6 square divided by 2 plus 4. So we will be getting a value of 12 watts, whereas the power is also same. So while converting a current source to a voltage source, the circuit characteristics did not change, but the physical parameters did not change. All the current value, voltage value, power value did not change. Only while seeing with the naked eye, the structure of the circuit had changed, but the current, voltage, and power value present in both the circuits are the same. Okay, if you have any doubts, okay, the next topic is we are going to convert the voltage source into a current source. Okay, this circuit given is the voltage source circuit. You can see Vs is equal to 6 volt and the resistance Rs is equal to 2 ohm and this is the load resistance RL. So now we are going to convert this voltage source circuit into a current source circuit. Okay, to do this, what we have to do in the initial stages, we are going to convert the series resistance into parallel. You can see in this, the voltage source and the Rs, that is the source resistance, are connected in series. So now we are going to convert this series connection into parallel like this. Okay, while we are converting this, we need to find the current value across the voltage source. To do so, we can easily use Ohm's law. Okay, we know V is equal to IR and I is equal to V by R. So this is the formula. I will be equal to V by R. Here IS, this is the source current. So we are representing as IS. V by R is nothing but Vs by Rs, where Vs is the source voltage and Rs is the source resistance. Okay, so Vs is equal to 6 volt and Rs, that is the source resistance, is equal to 2 ohms. You can see Vs is 6 volt, source resistance is 2 ohm and the load resistance is 4 ohm. Okay, so we are just substituting all the values. Now we are getting a value of 3 volt, which is, sorry, 3 amperes. Okay, now we are getting a value of 3 amperes of source current. 3 amperes of source current. Now we can substitute this 3 amperes in the current source over here directly, and now we are going to convert this series combination into parallel and redraw the circuit like this. Next, we can see after this 2 points all the circuits are similar. So we have a direct VL over here, then the load resistance is 4 ohm, which is directly connected over here. So to convert a voltage source to a current source, the only thing you need to do is you need to convert the series resistance into parallel. So you redraw the circuit, disconnect this RS from here and connect it over here. Then we need to use Ohm's law to convert the source current 3 amperes. By using I is equal to V by R, we can find this is the source current 3 ampere, and draw the circuit like this, and then from this point all are same. Okay, you can, from this point you can connect all the resistance and all the elements as it is. And then we are going to verify these things. The verification is same. Okay, you no need to verify anything because the reverse is equal, because we have already seen the current source to voltage source, this equations, this is same for voltage source to current source also. So I am not explaining in this slide. If you want, you can go further and see it. Let us move to the next topic, current division rule.
Sir,
Yes?
verification of voltage source, sir.
Yes?
12 watt இருக்கு sir.
6 at 36, yeah, 6 watts, yeah. As a typing. Okay, let us move to the next topic, which is current division rule verification. So this is a very simple question that may ask in your exams. Find the current through the two resistors in the circuit of figure A. Okay, this circuit is given, and this circuit, they will be asking how much current is passing through the 2 ohm resistance and the 6 ohm resistance. You need to find the current flowing in this two resistance separately. Then transform the current source and 2 ohm resistance to an equivalent voltage source and again find the currents through the two resistors. Compare the results. Can you understand the question? In this circuit, first we are going to find the current which is flowing through the 2 ohm resistance. Then we are going to find the current which is flowing to the 6 ohm resistance. After finding these two currents, we are going to convert this circuit, that is the current source circuit, into a voltage source circuit, and after conversion, we are going to find the current flowing in the circuit. Okay, let us now use the current division rule. Okay, this current division rule is very easy, and it is used to find the currents in the 2 ohm resistor as well as the 6 ohm resistors or any resistors which are used over here. Okay, in the question papers you may not see the same numbers as 2 ohms, 6 ohms or 16 amps. The numbers may be vary. Okay, but you need to use the current division rule, that's all. Okay, let's us find the current flowing through the 2 ohm resistance. To find the current, we should know I 2 ohms, that is the current through the 2 ohm resistance, will be equal to source current, which is the IS, into RL divided by RS plus RL. Okay, to simply explain this, I will say you to find the current through this 2 ohm resistance. Okay, you need to find the current through this 2 ohm resistance. You need to use 6 divided by 2 plus 6. Okay, very easy. To find the current through this 2 ohm resistance, we need to use 6 divided by 2 plus 6. Okay, that is the source current is same Is 16 into 6 divided by 2 plus 6. To find this current, you need to use this resistance at the top divided by 2 plus 6. Okay, then you will get a value of 12 amps. Whereas in the next stage, you are going to find the current through the 6 ohm resistors. To find the current, the formula is 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 into Rs divided by Rs plus RL. So I will say you 16, which is the source current, 16 into. To find this current, you need to use 2 divided by 2 plus 6. Okay, that's all. Very easy. So 16 into 2 divided by 2 plus 6, which will be equal to 4 amperes. Okay, if you have any doubts in this, we need to find the two currents. First, we are going to find the current through the 2 ohm resistance. Then we are going to find the current through the 6 ohm resistance. For the 2 ohm resistance, we are going to use 16, that is the source amperes, source current, into 6 divided by 2 plus 6. For the 6 ohm resistors, we are going to use 2 divided by 2 plus 6. So both the currents can be found easily. Next, we are going to transform the current source circuit into a voltage source circuit. So I have already said how to transform the circuit. Please try in your notes. Okay, please use a note to take notes while I am lecturing. So you can now try how it is done. I will give you 5 minutes. You can see, you can do your current transformation to voltage transformation in your notes. Okay, no problem. Okay, from the next classes, we do things like that. Okay, now we are going to transform this current source into a voltage source. For current source to voltage source, we need to transform the parallel resistance which is connected across the source into series. So to do so, what we need to do is we need to first find the voltage across the voltage source. To do so, we need to find voltage source, that is Vs, which will be equivalent to Rs into Is. We know Rs is 2 ohms and Is is the source current, which is 16 amps. Here is 2 ohms and this one is 16 amps. So we get a voltage source of 32 volt. Okay, first convert this thing 32 volt. Then we need to convert this parallel resistance, that is the 2 ohm resistance, into series across this voltage source. So what we need to do is connect this resistance like this, and this is the 2 ohm resistance. Okay, next you find the load resistance, which is 6 ohms over here. So we can directly connect the 6 ohms as it is. Okay, no need to change anything. And this is the 6 ohm resistance. Okay, now we have converted the current source into voltage source, and this circuit is represented over here. Okay, this is the source resistance, which is 2 ohms, and this is the load resistance, which is 6 ohms. Okay, we know the effective resistance when these two resistance are connected in series, we can just add these two resistance. What we can do is we can redraw the circuit like this. 6 plus 2 is nothing but 8 ohms, and here the source voltage is 32 volt. It is the same. Okay. Next, after transformation, we are going to find the current. The last point is again find the current through the two resistors. Compare the result. Okay. After this transformation, we are going to find the current through this circuit. To do so, you can see the current through this circuit is same. So the current I starts flowing over here, and the I current will flow through this 2 ohm resistance, and the same I current will flows through the 6 ohm resistance, and it will return back to the battery source. So the total current which is flowing through the 2 ohm resistance and the 6 ohm resistance are the same. So we are getting I2 ohm will be equal to I6 ohm. The two values are the same. So I2 ohm will be equal to I6 ohm, whereas I is equal to V by R, V divided by R. We know voltage source V is equal to 32 volt, and the effective resistance is we have find 8 ohm, which is nothing but 2 plus 6, which is 8 ohms. So 832 divided by 8, we are getting 4 amperes. So that's all. We have converted the current source into a voltage source, and verifying this, on seeing this, we can say the current in the second circuit, that is the voltage circuit, is 4 amps, whereas in here you can see in this circuit we are getting two currents, one is 12 ampere and other one is 4 amperes. So the representation of this is, while in the current source you can see the current I, this is the source current which is flowing over here. When coming to this point, the current gets divided into two branches. You can see we are having two branches of current. One is here, other one is here. Okay, this one is the source current IS, which is coming from the source. On this point, the source current gets divided into two values. One is for 2 ohm resistance and another one is for 6 ohm resistance. So we have already found the 2 ohm resistance current is 12 ampere. The 6 ohm resistance current is 4 ampere. So through this resistance, 12 ampere current will flow through this resistance 2 ohm, and through this resistance 6 ohms, 4 ampere currents will be flowing. Okay. Then after this 12 ohm current, 12 ampere current will leave this resistance, and the 4 ampere current will also leave this resistance through this point, and at this end you will again get the 16 amps. You can see 12 plus 4 is 16. Here also 16 amps current will be flowing. This 16 amp current will be divided into two parts, one for the 2 ohm resistance which is 12 ohm, and for the second part for the 6 ohm resistance is 4 ohm. After driving the current through these two resistance, the two currents get added up and converted back to 16 amps and again flow to the current source. Similarly here, only a 4 ampere current is flowing, and this current will be in series. So here also 4 amperes. After flowing through this also, here also it will be 4 amperes. Okay. If you have any doubts, you can ask in these slides.